Okay, hey Annabelle. I wanted to go over really quick sort of the methodology for setting up that stretchy single chain IK thing I was talking about. Before I got into the technical side of it, I sort of wanted to have an explanation of like what we're going to be doing and how it works, which does involve a little bit of algebra. Uh, you are not required to care about math, so if if you don't care about this part, skip to whatever time is on the screen right now. Um, But first, I wanted to break down sort of the problem that we're having, right? Is we've got like our leg joint chain, which looks like this, right? And this joint is being controlled by this control. And the problem is that whenever we move this control down like this joint chain does not change in size. And what we want is for this joint chain to actually get longer, to stretch out whenever we do this. And so the easiest way to think about this is just using simple math. So if we take the size of our joint chain as it is normally, the way you created it, we can think of this distance as being x, basically, right? This is how long the joint chain is when the rig is not moving. Now, if we want the joint chain to be longer, we have x, plus some extra distance. And I'm going to call this x plus n, right? And so this is basically what we're looking at, right? Is we've got x and we've got x plus n, and we need to figure out some way to scale this joint so that it makes this bone longer, right? And so all we'd have to do is divide, right? X plus n over x, and that will give us some scale factor. So the way that this breaks down is mathematically is this is just the distance formula. Don't worry about too much what this means. You're not really going to have to deal with it. But this distance between the hip and the ankle is what we're going to call x. The distance between the hip and our control's position is going to be our x plus n, right? As I put before, x plus n over x is going to be our stretch factor. And so the stretch factor is basically just going to be some number that we're going to scale our bone by. Now, I was talking about this a little bit too. If this number, x plus n, is bigger than x, then the scale factor is going to be greater than 1, and our bone is going to get longer. Hooray. But if this number is smaller than x, then our scale factor is going to be less than 1, and our bone will get shorter, which we don't want, remember, because we want the leg to bend or stay some minimum length so that we don't get any odd deformations. So we need to have a system that says if the scale factor is less than 1, we don't scale the joint at all, and it just stays the default length. And so basically the reason I'm telling you all this is because we can use Maya's node editor to set up a procedure that basically is doing this, but in the form of nodes. And so I'm going to get into that now. So I went ahead and set up this Maya file, which is basically what your leg looks like. We've got our hip joint, and beneath it is the ankle joint. We've got an IK handle. The IK handle is parent constrained to this IK control, so that when we move this control, it'll move around our bone. We've got a hip control, which just moves around the position of the hip. You'll see it works sort of like that. And this is basically how this is broken down. You can pause if you need to copy down this basic hierarchy. So there's a few things we're going to need to do if we're going to try to get this sort of thing going on, right? We know that this distance between the hip and the ankle is important, but we don't want to be referencing that distance directly from the hip and ankle joint, because when we're animating, these are going to be moving around a lot, right? So the first thing I would do is duplicate the hip and the ankle joint, just the hip and the ankle joint, like this. And we're going to call this hip scale joint. And we're going to call this one ankle scale joint. And so the purpose of these joints is they're not going to move with your rig at all. But these two joints have the exact same positions as your joints when it's in rest pose. And so that we know that the distance between these two joints is fixed, and it will always be the same. And we can use that as our x. The distance between these two joints is always going to be x, and it's never going to change. Now, for the same reason, we don't want to be when we're finding x plus n, we don't want to be taking the distance value directly from the control. So it's better to use locators. So go ahead and make 2 locators. I'm going to call this one hip locator, and I'm going to call this one ankle locator. You're going to want to take your hip locator and match transform it to your hip scale joint, like this, so that it's always right up here. And you're going to want to do the same thing for your ankle locator. You want it to match your ankle joint, so that these 2 locators, are aligned with your joints. Then you're going to want to put your hip locator underneath the hip control, so it always follows the hip control, and do the same thing with the ankle, except put it underneath the IK control. So now your ankle locator is always going to be following your IK control. So from here, we get to use the node editor. So the node editor is a little bit confusing, but once you know what all of your nodes are called, it's not so bad. So the first thing you're going to want to do is drag some of this stuff into the node editor, because we're going to work with it. If you select something in your outliner and click with middle mouse and drag it over, it'll appear in your node editor like this. So what we need, first of all, is we need our 2 locators. We need our 2 scale joints, like this. And we need our actual hip joint, the one that's driving your rig. So first we need to find x. X is really easy to find because, like we said, it's just the distance between these 2 nodes. So if you hit tab, you can get this box to appear, and you can type in the name of a node and it will appear. So I'm going to type distance. And you want to click this one that says distance between, and that'll make a distance between node. So in order to find the distance between these 2 joints, all you have to do is this part right here that says world matrix. You will grab this blue circle and you drag it into this white circle, click other, and then hit in matrix 1. You'll do the same thing with the ankle joint, except this time you want to do in matrix 2. And so now this node is measuring the distance between these 2 joints. Oh, and by the way, the way I'm opening and closing this is by hitting 1 and 3 on my keyboard. 3 makes it open all the way, and 1 makes it closed. Next, we're going to want to take the distance between our 2 locators, which will be updated in real time when we move our rig. So we can make another distance node, like this, hit 3, and we're going to do the same thing with the world matrix. Just plug this into in matrix 1, and plug the other one into in matrix 2, like so. And so now the distance between these 2 is being measured as well. Next, we need to do our division. Remember, we're dividing x plus n by x. So there's a node called multiply divide, which we will be doing our math with. So in order to get this to work, you need to have the node selected, and then over here go into your attribute editor. There should be an attribute for the operation of the node. You need to change it from multiply to divide. Now, if we take the distance and plug it into the input 1 x value, and then we take this one and plug it into the input 2 x value, it'll be dividing these 2 numbers. Now, when you do this step, these 2 numbers should be exactly the same. Remember, the locators are aligned perfectly with your scale joints. So these 2 will divide, which will give you the number 1. Now, if we take the output x of this and plug it into the scale x value of your hip joint, what's going to happen is you'll see this hip joint is highlighted yellow, and that means the scale is being controlled by your nodes. Now, if we try to move our IK control farther away, it scales up this joint to be longer, and our entire joint chain grows. Now, little Maya aside, you might have to select this joint, go into the attribute editor, and turn on segment scale compensate. I'm not going to get into why, but it's going to prevent things from breaking in the future. Now, we still haven't tackled the second problem with this, which is that if we move this control closer, it's going to shrink our joint chain, which there's a possibility will look weird on your rig. You don't have to do this next part, but I do recommend it. Remember, we're basically formatting this like an if statement. We know that if this value is larger than x, then we do want to scale our joint chain. But if it's smaller than 1, if this value is smaller than this value, the scale factor will be less than 1, and we don't want to scale it at all. So how do we go about doing that? Well, we can use another node in the node editor called condition. We want to use a condition node. So if you select it and you go into the attribute editor, you'll notice that this one also has a lot of operations like the multiply divide node does. We've got equal, not equal, greater or equal, less than or less than equal, right? So this is basically exactly what we're looking for. So what we're saying is if this number, x plus n, is bigger than x, we want to proceed with the operation. So let's set that up first. So we can use this distance between, which is between the locators, as the first term. And we can use this one, which represents x, as the second term. Now, if we change the condition operation to greater than, might actually work a little better if we do greater or equal. Shouldn't really matter that much, though. Then we can compare these two numbers, and if it's greater than or equal to, we can use some true condition and output some other true condition. So instead of plugging the multiply divide node directly into the hip joint, by the way, to undo this connection, you can just select this arrow and hit delete. What we're going to do is take the output of this and plug it into color if true R. That means if this condition finds that this operation is true, it will output some color. And so we're going to take the output of this and plug it into scale. Actually, now we're completely done, because if this value is smaller than this value, it will find that it's not true, and no scale will be applied to this joint at all. And we can see that in action if we mess with it. So this is pretty good. We're scaling our joint chain, but if I try to make it too small, it won't scale anymore, and it just works like a normal IK. This also works if we move the hip part. If we move this hip part, it'll also scale. You can probably see how this would be really useful if you're moving your character's hips around, but you want his feet to stay planted on the ground. Anyway, that's basically how this works. I'll send you this file, but good luck, and I hope you're able to figure it out.